Okay, we're back. This time with the microphone unmuted. We're decompiling Castlevania Symphony of the Night. You can learn more about the Symphony of the Night decompilation project at soten.z.dev. You'll find a link to the source code in the Discord server. We've been working on the sword familiar, and we'll keep doing that today. Last week, I started a function that was the biggest. It seemed like the main state machine driver, and I poked around a little bit with that before the stream, and we could keep going there. I don't think there's a lot of interesting things there, so I'm going to pull a different function, and hopefully we can get end to end on that. Good to have you, Mr. MIDI. Retro, oh, good evening. Good to have you on the stream. First time chatting. Nice to have you. So yeah, let's start. So I was, let's see where I pulled that. First tab here. This is just a support function. It looks like it's primarily targeting primitives, so how the sword is drawn, or some of the effects related to the sword. As always, I don't know exactly what this function is yet. I haven't stepped through and seen if I could hit a breakpoint where this function is, and maybe we can do that later on. So some of the things are going to be blind. I don't necessarily know what some of the globals are, but hopefully we can try to figure that out. There's still a lot of globals within the sword familiar that their purpose is currently unknown. So I pulled this from the assembly. You can go back to previous streams if you want to know how that's done. Oh, awesome. Welcome back, Roaming. Nice to have you. Weapon 30 was the last weapon in the Weapon 0 overlay. And I think we got it to, I don't know, somewhere in the mid-90s on the stream. And Roaming went and finished it off. And I did notice in Discord there was some issues with, I think, the how the jump table was getting aligned, if I remember correctly. And depending on how we go on this, maybe we'll look at that as well. That'd be super cool to have all the weapons decompiled. So to start, we need to get a type for this variable. It looks like this is going to be a pair. So we have these two variables that are contiguous in memory, both 32 bits. The GCC, when it compiles it, it can calculate those offsets. And so it looks like it compiled it to one thing. I'm going to assume that it is a struct. It is possible that it's just a array. That happens pretty often. Let's do that. Oh yeah, the return type issue. Yeah, that showed up a lot in weapons. Okay, so I'm gonna start with that. We'll use 0.32 for 5C, and that should get us compiling at least. And then when 660 is being used, it can just be the Y field. So we have another structure that is unknown, and we might be able to figure out what that structure is based on the offsets. So let's go down to line 84. and figure that out. We don't even need that much information, so this is going to be a primitive. I'm not sure why M2C, so M2C knows that it's a primitive pointer. It's possible that there's some alignment issues here. So let's open that up and see. Hey Eldritch, good to have you back as well. So I'm going to look at the primitive header. And just want to see what's at these offsets that would be causing problems. Yeah, so X0, X1, those are well-known fields. The only thing I can imagine is that they're being used as possibly 32-bit integers. It does tell us that this likely now isn't a .32 because we have two different X values. So I'm going to switch that while I'm here to an array. So we have a bunch of these. Let's see how far I can get with a bulk replacement. Oh, sorry about that. Get back here. So I'm just looking at all of these unknown fields and using the offsets in the primitive structure. And it looks like these are all related to the X value. X value, excuse me. Okay, a few more. 113. This looks like it could be something similar. Oh, this is our array from above. Yeah. So we just need to fix those. And everywhere there's this, we can change it to offset 1. Everywhere there's a 0. We can change that to offset 0. And my guess here is that this is the same thing. GCC has just decided to load this base address instead of loading this address first. So we're compiling. That's good. The top looks pretty perfect. And then down around line 69 is where we see issues. This is going to be a for loop. There's some things here with go-tos and blocks that should be easy to rewrite, just out of order stuff that, not necessarily out of order, shared code where that shared code isn't necessary. I am going to turn off built-ins. The normal caveat applies there. We do use built-ins for GCC 2.6. However, the function signatures are provided by the PS1 SDK, and those function signatures are different from what GCC provides. Lion Guru, thank you very much. Appreciate it. So I'm going to go through and start getting rid of these temporary variables. So a built-in, they're also called intrinsics. So they're things that look like functions, but really the compiler is going to treat them in some special way. So for example, we see absolute value a lot. And so you have abs some value. It looks like a function. Yeah, that's right. And so abs is a good example because on GCC it is an intrinsic, but in MetroWorks it's not. And so you'll have the same code. GCC will just inline that absolute value calculation. And then MetroWorks will actually make the function call. This is, if you've been on the stream before, this should all look very familiar. This is how primitives are always allocated and checked. It looks like var t2 is going to be our I variable. And so we have 16 of these primitives. That one. Usually this shows up a few times. So what did I screw up along the way? Oh, I got rid of my equal sign. Okay, so we should be tracking pretty closely. Some things are going to change. So here we have some offsets that are wildly different. But everything else is pretty good. 35. There is an odd value difference. We'll see what happens when we get there. So I'm going to rewrite this as a for loop. I don't know if much care is needed. Before I do that, I'm going to rename var t1. The alternative ones, T2 and T3, we're gonna call them all the same thing. They're just gonna, and we're gonna get yelled at because we have multiple declarations now of that prim, but they can all be the same. This one as well. Excuse me. Potential spam. Okay, so that's much easier to read. A bunch of these temporary variables up here that are being used to set values. Are those calculations actually happening that early or not? That's hard to know. My guess is not, and then a bunch of this is going to get reordered. But let's do the for loop first. So var t2 was our I. We're not going to need these two, and everything else looks like it's just going to die. So a huge difference in those. Let's see what may have happened to cause that. Yeah, there's some ordering here. I'll get rid of all these temporary variables, and then we'll see if that resolves itself or not. Usually don't expect something that major. I'm going to rewrite these before getting rid of those temp variables. So I think the open question before I move these down is whether or not colors are being set before coordinates. I'm not sure. So let's move these down and see. temv0_2 is I+1. That's where the complaint is coming in. I am going to look at that beforehand. Yeah. That's why it's not here. And now these should be... Oh no! Browser failure. Well. We have to start over. Oh no, there we go. Yeah. Save! That's working like I expected. So we have most of those calculations now, or all of them moved down. So the next thing is to figure out, is this the correct order or not? And looking at how this worked out, it does look pretty good. There is some garbage down here at the bottom that may or may not be related to how this is being done. The way that this go-to is set up, I think is screwing things up a little bit. And so we can kind of work through the cases there. So the default case is setting this particular value global to 0 and then returning. If we look at all of the other cases, block 21, case 1 goes to block 21, where we fall through and do that. Case 2 goes to block 22, which is here. So this shouldn't be a default case, it should just be happening at the end. And our our options are either to increment the step and break or not. And GCC likes to go through all kinds of contortions to not do that. Okay, so this is slightly different. We're decrementing the step instead of incrementing it. But otherwise, same logic. So that cleans up the bottom of that loop then. And all of that looks fine. We have a register mismatch. There was this up here where some of these constants were wrong. Let's see if we can figure that out. These are just misorderings of these fields. And this is pretty common. So, no big deal there. All right, so the next issue is on 54. This is another for loop. This time we're decrementing instead of incrementing. Possibly not. We'll see. 10 people on stream today. Busy day. Hope everybody's had a good, here in the US, had a good holiday weekend. Ate lots of turkey. My turkey turned out great. And then I took that turkey and I made soup out of it. And that soup turned out great too. So let's write it backwards and then we'll see if it matters. We do need to decrement instead of increment. That'd be helpful. So we're matching, which is good. Let's flip that around. This should be basically the same thing. We're looking at primitives. We're going to do this e times. So that's 14. So what we really want is the last primitive, but it's a singly linked list, so we have to walk the entire list. So that would be the same as prim count minus 1. And let's see if that makes a difference. I think it should compile to the same thing. And it does. So GCC is rewriting this as a decrement instead of an increment. It doesn't affect us either way. So no huge concern. So this is interesting. This is why M2C wasn't generating the right thing. Instead of loading two 16-bit values, so this looks like it's setting prim x0, y0, but it's doing it as a 32-bit operation. Whether that's intentional or not, I don't know yet. But that does mean that this isn't assigned 32. It's going to be a 0.16 or something like it. It could just be pairs, an array of pairs. So we're going to have to go through and fix all those. But it looks like what's happening is X and Y are both getting set, and GCC is just turning that into a 32-bit operation. I'm going to have to go through and fix all these. So that's likely that's what's happening everywhere. And like I said, whether that's happening magically through the compiler recognizing that those are contiguous or not. Yeah, that's the issue. Is so roaming asking, is this an intrinsic copy? And it possibly could be. The issue is X0, Y0 are independent fields, and those fields are actually defined as the PolyGT4 from the PlayStation 1 SDK, and the unused fields or padding fields in there are just being reused by Soten. So we do have to treat it that way. We could use the load word macro on both of these, and that would work. It would be interesting, I think, to see how the PSP is doing it, because that might tell us what exactly is going on. It's also possible that this is just an array of 16-bit values, and because they're contiguous. So we could try that. It's going to screw up all the other changes I just did, but that's okay. It's possible that GCC will take more leeway if it knows that it's loading. I'm gonna do this as well. Just make it so it's clear that it's 232-bit loads. No, it's not. Maybe if GCC knows the size, maybe it would trust, because it doesn't know at this point whether the next index is actually part of that array or not, and it can treat it safely. So let's look at the definition and try to get the size. So we're in servant TTO4 data. Oh, and it would help if I told it what I wanted to search for. Oh, bummer. So this is SPSS, which means we don't have anything to go on other than it looks like 4 pairs. We're only using 2 of them here. So I'm going to say that's a 16 of size 4. But that doesn't help. I was hoping that if GCC knew that it would generate those instructions. So it's either 4 contiguous XY pairs or 2 contiguous XY pairs. Yeah. And the other thing is, we'd have to look at the writer. Let's see if we can find that, if we can find the writer of these values, because this function is just reading them. We can look at, see if this has been decompiled yet. Don't recall this one. Not PSP. So we're looking at F8. So we have F8 and 8.4. Neither of these are writing to it, though. Oh, that's not true. It could be that. Let's see. We're doing F8. It could be that the address is being loaded into T8 and then being written to later on. Yeah, that's what's happening. Actually, it's a little different. So we're sending these values out to the geometry coprocessor. I'm not sure what the order of this instruction is, if it's writing to the value at the 0 offset or not. I'm not very familiar with those instructions. So there is a store happening here of word size, but nothing ever to offset 1 or offset 4. Sorry. So it doesn't look like this second set of coordinates ever gets set and is always 0. So in the meantime, what I'm going to do is just cheat and use load word. And that will give us the right instruction. And it is not optimal and not the most portable either, but it'll match. Yeah, so there's you could package up to 2 coprocessors with MIPS, and so the geometry engine is one of those coprocessors on the PlayStation. Some MIPS chips would use it for their math coprocessor, but yeah, it just stands for coprocessor 2. Okay, so forcing that array load works fine. I'm not going to fret over it not being perfect. Like I said, it might be interesting to look at the PSP version later and see what that is, if it's doing something different. All right, so we have another loop that we need to get through. This time, it is being written in the normal way. My guess is that this is a flag, so I'm gonna remove this. Again, the PSP value is gonna tell us, or the PSP version is gonna tell us if that's a actual equality versus 0 versus just truthiness. Let's do our and I'm going to say so in this case, we're skipping the first primitive. We're doing grabbing the next item in the list right away. Oh, what I missed when I was doing all my my replacements is that we needed both of those. So we're copying things from the next value over to our current value. So let's make a new pointer. And we just need to make sure now that we are doing the assignment in the right direction. So are we copying from thank you. Are we copying from my guess is the first one to the second one. So let's try that. That does look right. We have something very similar again. So what load word does is basically cast this to just a sine 32. We could do something similar ourselves and say that this is a 0.16, and we're assigning it to the value here. And so this is what roaming was talking about earlier. Is this just a copy instruction? Slightly different instruction though. I would have expected that to generate the same thing as load word. Load word's doing the same thing, but with the sine 32. And that's what's happening here as well. It's really a little strange. We've covered a lot of this primitive drawing code, and this is not the way it typically is written. So it seems like maybe a different dev was working on the sword than the normal group. There's some differences down here that need to be resolved. I think it's usually draw mode, then priority. And these may be happening later. So we need to priority in draw mode. Yeah, that's better. So this is more of the same, these load words. There is this move here. So this is the increment of I that appears to be happening out of order. It's possible that something down here that's missing, once these are cleaned up and matching, that will resolve itself. So I'm going to go forward with that and see if that works itself out. It definitely is possible that it's a that the loop was written as a while loop. So now we have the wrong order. I'm pretty sure these will come after. No, or not. The order here seems to be wrong as well. Let's back up. All right, so something not quite right is happening. Let's look at this just to make sure that the branch is going to the right place. So the 6C value is being loaded. The mask value find this mask. Now we need to okay, the mask is happening there. Let's see, 1426. Yes. Yeah, and so the draw mode, I stopped fixing those on the stream because our linting tool will do that already. It'll see that this is in an inverted flag. So there's still something funny with the ordering. Oh, this may need to be okay. So this is a little odd. My guess is that these are actually backwards. Let's try that though. Once more, draw mode first. I can just look up here. What comes first, draw mode or priority? Priority's not up here, so that's not helping me. Up here we have priority before draw mode. Are these looking better? This isn't. So the it does look like that was being done backwards. So we're taking the old X0 and X1 and doing that assignment first. I didn't think about this being reading the old values. So now this looks like it's out of order. Is that closer? Not quite. Our store to 26 and 32 may be happening in the middle of all this. That doesn't look good either. Let's try your newfangled thing. Option. It's option for me. Taking too much though. Okay, so we're loading offset 14 and we're loading offset 8. It's possible that these are coming out in variables. And then those variables are being assigned. A little odd. I'm going to keep going and see if working any of this out lower down changes that. There's, yeah, just a lot of things that I don't necessarily expect in this function. So I'm going to try to get the more straightforward stuff sorted out. These offsets down here, this all looks like the same type of pattern where we're doing the loads. This looks like it might be an assignment like that, just a pass-through assignment. And the way that this, if it were so this would have to be like point structure assignment rather than assigning X and then assigning Y, because I don't think GCC would interleave those and optimize that way. It is possible as well that there's an alternate version of primitive that's being used here. And that's not out of the realm of possibilities, for sure. So the last part then is really just this, and why these end up in this unexpected order. So we're getting these register differences, and oh, that makes me think that yeah, that's likely. So I got these wrong. We are going backwards. Oh, and that's likely what's happening down below as well. I didn't even think that that's still an issue with the yeah, it's possible that this is pulled up. I would expect GCC usually to do that by itself. And so this part down here is the same, I think. Let's see. Possibly not. Now we're at the last element, and so we're going to do something different here. We don't have a next at this point, so we can't use next. So let's save that before something catastrophic happens. And let's see if we can get this up. So whether or not this store to 20 happens first or second is important. All right, so we're loading offset 14, which is this one, and then assigning. That's we should expect this offset 8 to be done first. So this is happening out of order. There's a couple ways to force the order. I don't think it should be necessary. There's some load, like on line 75 here, we're loading a half word. Yep, you're right. Line 81 is superfluous now. So our last, the last thing we should be doing is assigning offset 32, and offset 32 is sorry, that's wrong. The last thing we should be doing is loading 660. Which is then doing the store into offset 14. And offset 14 is this value. So that's correct on that ordering. I'm at somewhat of a loss as to why this is not working out. Really, it's the ordering, these instructions here. There may be something that I'm missing. Let's go look at the decomp again and see if I screwed something else up. If I took out a variable that I shouldn't have, or otherwise. So our next is, like we expect, what we're pulling all that data from. This has a very different ordering for priority and draw mode. It is possible, and I'll try this. That's not very common. And so I think this, oops, not that one. I think this might have to go through the permuter. Or we'll pull the PSP version. Let's do that. So we have a nice unique value up here, this OC82. I'm going to see if that is unique enough to get us a PSP version. Oh. Okay, so slightly unique. We want one of these 4. So we have 2 here, 3 here. So likely this function, because we're only using that once, and the function that we. And just a quick spot check. So we have that same 141, 1E, 1B. So that looks similar. Let's see what the size is. We're at about 250 lines. Oh, it's much shorter. So maybe not that one. Okay. Let's look again. Like this. I will look at that. Yeah, so I would expect there to be 141 in here. Well, let's go back to the other one. I mean, it's possible that it is the right one, but it seems too short. Yeah, it looks like it. Okay, well, that's a little surprising that it's so short. Let's get a good starting point there. In PSP context, we need an additional field in our primitive structure. Fresh decomp. So still a few things that are wrong in that one. I'm going to pull this over and that gets us very close, even on the PSP side. So on line 36, there is this draw mode assignment, which seems to be not on the PSP. Oh, it is. It's just not in the order that it is here. So that may or may not affect this. It does not. So the PlayStation version is immune to that change. And on line 74. I'm hoping that this does give us the ordering. So this value, the type of this seems to be wrong. And let's see if that cleans up the PlayStation version. It doesn't. Okay. We're running out of wrong things on the PSP side. Yeah, the PSP side actually matches now. I think all of these are just constants that are legitimate differences between the two versions. So we have a a matching PSP, but a non-matching PlayStation version. I do want to see, just make sure that these are all load words. They are, because it matches. Well, we don't need the return down here. All right, so let's go back and figure this out. So we're doing the assignment to offset 26. Storing a half word. So this X3 assignment is happening, and the X2 assignment. Those are happening much earlier. So here we have our load word. So that ordering is correct. This is just... the sequential ordering is right, chronological ordering, but the this X0 field is being loaded earlier than expected. So I said we can force this and give GCC something that it won't try to reorder. And it is still reordering these two statements. But it does look like the other stuff then did fall into place. And that's a dirty hack. Oh, one thing I didn't consider is what is this particular data type. It's doing a load high unsigned, load half unsigned, but it is possible that sorry, must be doing a load word. It's possible that that's an array, and that we're getting different addressing because of that. So let's try that. Or a struct or something else. So that's coming into A0. So this is being stored at offset 26, but it's being stored as a word. And let's look at what is after priority. I'm surprised. I'll have to go back and look at the PSP version again. R3. It almost seems like this is also being stored as a 32-bit value. Oh no, it's not. Yeah. No, so it is not being stored as 32-bit. Let's try to make this an array and see if that changes the order. Alright, so there's something else going on that I'm not sure of. That is causing the ordering there to be funny, but funny in a way that it's not on the PSP side. And the PSP side that matching may mean that there's a bug fix or something like that that is in here between the two. Yeah, I don't see anything else that's notably different between the two. So I'm going to take that over and put it in the permuter, and we'll see if the permuter can figure anything out with that. For fun, like roaming's other function, I will try changing this to an S32. Yeah, it doesn't have any effect here. Usually that's affects how the V0 register is used, or V1, because those registers are used for return values. But what we're seeing is we expect this load to be happening first, and chronologically in our code, or sequentially in our code, that's how you'd read it. It's actually doing this draw mode read. No, sorry, this X0 read first. Oh, one thing that I didn't consider, and might be interesting, just changing the variable to next, because next and prim are the same thing at this point, but they were in different registers. So, yeah, it doesn't make a difference. I was thinking that possibly GCC thought, well, I have prim cached, but next wasn't cached, even though they're the same thing. Okay, so I'm gonna take this, and the size didn't end up mattering there. I am gonna look at this 866C. This is also in BCC, so it's probably not going to give us any great information. It doesn't. There's no jump table in here, so I'm not worried about alignment. I haven't had much luck with the permuter recently. Just to make sure the workspace is clean, I will make it. Yeah, everything is fine there. And the failure is expected. Our size is going to be different, and some of those instructions there. So doing a diff would be hard because it's going to shift all the other offsets. That's it. The base score changes. Oh, it did find something pretty quickly. So down to 140. Let's look at that and see if there's anything. novel. So it's pulling these. Oh, and there's an 80. It's pulling that x value out into a variable and then assigning the variable instead. I could get behind that. This is the do while trick. So let's try that on the PSP first, and then see if that works on the PlayStation as well. So instead of loading these values, love to hate it. Yeah, the big issue I think with it is it represents something that we don't know. And I've been thinking about this regarding like cross-platform support. Any of these hacks that we're doing for like assuming the layout of a struct are oh, there's a 30. And it's the same thing. So let's pull these out into variables and then assign them. It should be XY, it should be X0, X1, but so that's pretty close. Where the permuter put these was actually way above this loop. I don't think that's necessary. And let's see if the PSP is not going to be happy with this because it expected it expected the store. Oops. And it's giving those variables S registers instead of just reusing the V registers. So it's not a PSP compatible change. I am going to try moving this down. Maybe even to the bottom. So close, but yeah, I mean that is possible. I think I'm going to leave it here. Yeah, I'm really not sure what. what might be going on there. So I'm going to save this off, and we'll go look at the weapon 30 function. And I'll leave the permuter going. And we'll see where that gets us. All right. So let's see. So this is Mr. Midi's. Let's look at roamings. These huge buffers are interesting. And so, just to go over what Roaming was saying earlier in the chat, I'm going to see if this has a definition down here that it's going to screw me up. Most of these functions, the default declaration is actually, I wonder if they're just undefined. That probably is what happened. But the way that they are declared is as if they're signed 32. And look at how different. So going from 115 differences, which appear to just be these immediate values, which is expected. To having this as a signed 32, and we're at 325, so 3 times the differences. And somewhere down here, we're probably going to run into register issues. Actually, this is an ordering issue for these values, but the basically this line here got moved down too. For what reason? Who can say? Because it's using the V0 register anyway. The V0 register has to be cleared out. If this is a signed 32, it has to be cleared out before this function can return. But that ordering doesn't make a difference. But there must be some mode internally for GCC that affects that optimization. Awesome find. Good job, Roaming. And let's go back. We'll look at that. Let's see what... Yeah, so we do have a 30. The 30 just came from adding a new variable. Not sure what... I'm going to undo this so that we get a clean build, and then we'll go look at the weapons. Fingers crossed. Now it looks like I don't have the W factor. Oh, I do. It's just in this for... I think Weapon Factory is now in the main includes. Maybe just in the weapon includes? Some weapon private. So there's a slight difference between this Weapon Factory implementation and the one that is checked in. So here we have ID and Fram, and it looks like the difference is A and B are being combined. So we'll just have to do that here. I think that should be the same. If that isn't, I will go back and it looks like there is a field name that has changed. Oh, and we need to rename this function to get rid of the W30. So let's find that. So we need this variable. Which is an entity. I'm gonna do a search for that address. Let's see if that's a named entity. It may be an entity at a known offset. No, it's just known as an entity by that name. That many weapons use. Make sure that's externed. And then two declarations of function pointer. I think that's because this is not compiling. And then looking for this address too to see if so that's gplayer timers. Oh, one more. 15. Okay, so 9C. We'll find that. Yeah. That is hard to come back to scratches that have been sitting for a while. That's okay though. It needs to be done at some point. So 9C is going to be in our if this is a weapon, this will be acceleration X. That's safe to assume? Maybe? Oh, there's a weapon 030. Thank you, Mr. MIDI. And we're just at same thing, but in that weapon strap. So unknown 9.8 and 9A. There is no 9A right now. 9.8 being a 32-bit value is a little worrisome, as it is being used elsewhere. And so we need it as a 16-bit value here. Oh. So I think there is a macro to disable this declaration. There's just so much messy stuff with this, with weapons. And that happens when you... so we can set Func 04 Void before including weapon private. And that'll give us the right declaration. And something wrong. And I think what I'm going to have to do is... oh no. I think what I'm going to have to do is probably re-import this with current symbols and... thanks, roaming. I'll try that. And if that doesn't work, then it may require at least updating those structs. I'll get back to where I was. Originally this was... generic unknown 9C. And that was an entity pointer. So let's leave this as factory for now, and see if that works. I'd rather have it work, and yeah, still a big diff. So something else is going on here. It's so here this FC versus F8 offset or address is different. I'm going to back out as much of this as I can. That one I'm less concerned about. Is factory. So 9C here is at S16. So I need to find a 9C. I just want to get the... Oh alignment correct. I want a 9C that is a pointer. I guess anything that is a 32 would be fine, because it's just checking it for non-zero. Obviously not something that can be checked in, but we'll do fairy. Oh, I lost my... Okay, so there's something else going on that I need to look into. It does seem like symbol names probably just need to be updated, and that we will need that. This struct looks like it might be a little different from the 030 struct as it currently is. And possibly it's just that this is an entity. I'll take a look at that later, though, and I'll make sure that if I submit a PR, I'll include you as a as the contributor, or maybe I can force the author as you as well. But yeah, that's awesome. We should be able to get that in. I probably will play with that a little bit tonight and see what we can do. Thank you very much, Roaming. That's all the time that I have. Thank you for tuning in to Made Up of Wires. I really appreciate that people come and are interested in learning more about Symphony of the Night and this decompilation project. Go to soten.z.dev for more info and to see progress on a lot of the overlays. So if things go well tonight, this weapon 0 will go from 98.75 to 100%, which would be awesome. So look forward to that during tomorrow's stream, and we'll see if that gets to make it there or not. Join us on Discord. And if you're interested in helping, we have lots of resources to get you set up and get you decompiling. Otherwise, like, follow, subscribe, do all the things. And I really appreciate people stopping by. I'm here Monday through Thursday, starting at noon Pacific time. Join us and have some fun. Adios. No, maybe it's 11 Pacific time. Time zones. They're tough. Bye.